we are going to discuss Unit 5. Okay, curve fitting. Unit 5. Fourth unit we will be discussed after completing Unit 5. Okay, so last time we have discussed Unit 3 and we have completed Unit 3 and right now we are going to be discuss Unit 5. So after completing Unit 5, we will going to be discuss Unit 4. So Unit 5 is am I audible? Okay. Yeah. So first we are going to be discuss introductions, least square method, fitting of linear curve, fitting of quadratic curve, fitting of exponential curve. So these are the outlines. In this chapter, we are going to be discuss least square method, linear curve, quadratic curve, and exponential curve. So in this chapter, mainly we are going to be discuss linear and quadratic curve. Okay. First of all, what is curve fitting? Curve fitting is a tool to fit analytic equation to a set of measured data. Suppose you have given n number of data in two-dimensional x1, y1, x2, y2, xn, yn, and from that you want to find out a curve which fit to this data. Okay, so this we call it a curve fitting, best curve which we want to find out here. Like suppose you have given this data here in blue dot, there are some data and echo. We want to find out this here. We have find out this curve in red line. This is the best fit for this data. How we can find out this curve, which we discuss later on. First of all, this is the example that the analytic functions we have find out for a given data. Okay, and so these functions which is f of x is equal to, you can see that this will look like a parabola. So f of x equal to a plus bx plus cx squared, quadratic equations here. Here a, b, c, which are the constants. Okay, and f of x which represent the best fitting of a curve for a given data. Why do we need the curve fitting? So observe and quantify general trend. Okay, from the data we want to generalize the trend, then we need a analytical functions here which we have to derive, and we can estimate the future value from the curve. Fit experimental or measure data to analytic equations. On the basis of this analytic equations, many prediction can be made. That's things which I have said. You can predict future value from the given data. Okay, so if you find out the curve, then you can predict the future value. Remove noise from the functions. Noise, it means error. You can Hello. Okay. So the analytic functions enable to use of calculus to find maxima and minima. Okay. So how to do curve fitting here, which we discuss, and we use least square technique to find the best fit to a curve. Now, least square technique means, uh, like suppose you have given some data here x1, y1, x2, y2 up to xn, yn. So we want to find out a curve such that you get the distance between the point and a curve which is minimum. So, but now see this distance. If I find out the value difference between these 2 points, suppose this is something x comma y and this is x1 y1, then uh, y1 minus y. So this difference you get it positive, but here you get y2 which is less than y, so you get a difference is negative. So what we do, we take the square of all this. So how we find the distance? By taking the square of a difference. Okay. So we take the square of difference and sum of all square of difference, and we will find out which one is minimum for this curve. Okay. So what we do first, we take this endpoints and we consider some function. Suppose y is equal to f of x, which we want to find out what is f of x here, and then noise or error between the measured data and the point on the curve is now this, which we take e1 square. We call it this difference between, so distance between these 2 points. So this is e1 square, which is equal to y1 minus f of x1 whole square. Okay. Similar way, e2 square, which is y2 minus f of x2 whole square, and in this way you can find out for each point, and you get this error e1, e2, and up to en. So what we do, we are taking square because this quantity might be negative. So, and then otherwise if we take the sum of all this, then it will be cancel out. Okay. So we need find out the minimum distance between the points and a base fitting a curve. So what we do, we take the sum of all this and find out the a minimum value of it, so that the which is the best fit a curve. We call it a least square method. So sum of error at all points of the data is given by E is equal to summation ei square I from 1 to n. Now this ei, it means yi minus f of xi. You can see that here this is y1 minus f of x1, y2 minus f of x2, yn minus f of xn, and which we get from this. Okay. And here on this line, this x1 is same for both. X1 is same, so x1 minus x1, which is 0, and which we get here y1 minus f of x1, y is equal to f of x1. Okay. So this is this point is my x1 comma f of x1, this point is my x2 comma f of x2, this. Okay, in this way this point is my xn comma f of xn, and we take the square of the difference of each point, and then we take the sum of all it. So sum which I get here, summation ei square I from 1 to n. Now I want to find out a curve. So for that I want to find out f of xi such that this sum will be minimum. Okay, this is our least square method. So best fit curve has a minimum error between the curve and data points. Now how we will do it? So for that we use the calculus here, as we know that if you have analytic functions, then you can find out minimum and maximum value, okay, from the given functions. So now first we do for a linear curve here. Okay, linear curve. So suppose we have x1 y1, x2 y2 up to xn y1 be a set of measure data, and now y is equal to f of x equal to a plus bx, a linear curve. We want to find out f of x equal to a plus bx. So here a and b, which are constant, is a linear curve which we want to fit for this data. Okay. So, and sum of error at all points of the data given by, this is summation I from 1 to n ei square, so which is nothing but summation yi minus f of xy whole square, I from 1 to n. Now we can replace this f of xi as a plus b xi. Okay, a plus b xi, and here we want to find out a and b. Okay, a and b is our parameter here. So yi minus a plus b xi whole square. Now this yi minus a plus b xi whole square. Okay, so we have these functions, sum of all this square, and if I want to find out minima or maxima for this function, so here see this xi and yi is fixed, xi and yi which are fixed, x1 y1 x2 y2 xn yn. So here parameter is my a and b. So what I will do, I will take the partial differentiations with respect to b and a. Okay, so to find out the minimized functions, okay, with respect to parameter a and b. So if I take the partial differentiations of e with respect to b, what I get? So this is power we have 2, so 2 into yi minus a plus b xi. Now in differentiations of these terms, yi minus plus a plus b xi, so yi is constant with respect to b, so this is 0. A which is constant with respect to b, which is 0. Now here bxi, so what I get with respect to b, so xi is constant into b, so I get xi, and we have minus sign, so minus 2 xi into yi minus a plus b xi. So see here you get partial differentiations of e with respect to b, minus 2 xi yi minus a b plus xi, which we take equal to 0, as we know that at a differentiation equal to 0 we have a slope 0, which at that point we get either minimum or maximum value. Okay, as we know that derivative describes the slope, and when slope 0, so at that point we get the local minima or local maxima. So first we take the partial differentiation with respect to b. Now similar manner, if we take with respect to a, so what I get, minus 2 into yi minus a plus b xi. Now with respect to a, so here I get 1, but this term will be 0, so 1 into minus, so minus 1, so this is minus 2 yi minus a plus b xi, and which is equal to 0. So first we take del e by del b is equal to 0 and del e by del a equal to 0, which we get these functions. Now for the simplifications, what we see, first of all this minus 2 which is constant for each term, so we can take outside the summation in both the term. Now we multiply both the side by minus 1 by 2, so this minus 2 will be cancel out, Now this yi minus a plus b xi, and this summation I from 1 to n. So I will remove this suffix. Okay, I will not mention the suffix right now for easy simplification. I just write summation. This is xi yi. Okay, so I will what I get. Okay, what I do, I just divide by 1 by 2. So I take this minus sign. So this minus plus summation a. What I get, summation a minus summation b xi, and then minus summation xi yi. So this if I remove, then summation ax plus summation b x square minus summation xy equal to 0. Once again we have this del e by del b equal to summation I from 1 to n minus 2 xi yi minus a plus b xi. So I will take 2 outside and then multiplied by 1 by 2 on both sides, so 2 will be cancel out. Now this minus xi into yi, so minus xi yi, then this minus plus here, so I get a plus b xi. If I apply the summation and remove I, then what I get, this summation ax plus bx square minus xy equal to 0. Okay, now here I have not mentioned I, but it means this is I from 1 to n, this summation which from I from 1 to n. Now similar manner for second equation, I get summation a. Okay, if you look at here second equations, again I will cancel out this 2 and multiply it with minus, then minus yi, minus plus here. So if I apply give the individual summation, then I get summation A plus summation bxi minus summation yi. So summation A plus summation bx minus summation y. Okay, so this summation A plus summation bx minus summation y equal to 0. And therefore this, I can say that this A summation x plus b summation x will equal summation xy. And now this A is constant and I varies from 1 to n. So this sum A plus A n times. So I get n A. And here b constant, so we take outside summation x and is equal to summation y. So this is our normal equations. We will use these equations in example, okay, to find out a linear curve, best fitting linear curve. So you have to remember these two equations if you want to do the example. If you want to apply these equations in example, you must be know for all this, both the equation. So I suggest you note down this: a summation x plus b summation x squared is equal to summation xy, and second one is n a plus b summation x is equal to summation y. Okay, so these equations are called normal equations, and by solving these two simultaneous equations we get the value of a and b. Okay, so now to find out the base fitting curve, so what you have given in example, you have given x and y data, xi and yi. Then you have to find out this summation x squared, summation xy, summation x and summation y. So first you require to be draw a table in which you have to find out x square and xy, and then take the sum of this x, sum of y, sum of x square, sum of xy, and put all this value in these equations. So you get a two linear equations in terms of a and b, and by solving these two equations you get the value of a and b. Once you get the value of a and b, then you get the this curve y equal to a plus bx. So you must have to remember this normal equations. So I suggest you note down this. Okay, note down it: a into summation x plus b into summation x squared is equal to summation xy, and second one is n a plus b summation x equal to summation y. And here y is dependent on x. Okay, y is dependent on x. If x is dependent on y, if x is dependent on y, so instead of x I get y, and instead of y I get x. Okay, so now normal equations for a quadratic curve. Here previously which we have discussed for a linear curve. Okay, so this is normal equations for a linear curve. Now similar manner you can find out for a quadratic equation. And your quadratic equations here, f of x equal to a plus bx plus cx squared. And after applying similar process which we have done earlier, then what I get, this normal equation summation y is equal to n. So here you get three linear equations, and you have a three variable here, three parameter a, b and c. So in terms of a, b, c, you get a three linear equations, and you know that how to solve these three linear equations for a three variable. You have already learned about the Gauss eliminations method, Gauss Jordan method. By finding inverse of a matrix, you have also find out x equal to a inverse into b. So you have to note down this formula. This is also a normal equations for a quadratic equation. So I suggest you first of all note down this one, which we will use in example. Okay, so you require this formula in example. I give you 2 minutes, just note down it. Okay, so I hope everyone have noted down this. And how you can remember this seal, like this summation y a n plus b summation bx plus c x square. Now I multiplied x with these equations, so what I get here summation xy. Now instead of na, what I get if I have ax summation ax here. Okay, here na which I get summation a, actually this is summation a. Now if I multiply it, then I get summation a x and b x square and c x cube, and again if I multiply it with x, I get summation x square y ax square bx cube plus cx raised to 4. So whenever we are finding a best fit quadratic curve, then we require to be find out summation x, summation y, summation x square, summation x cube, summation x raised to 4, summation xy, and summation x square y. Okay, all these things. So you have to draw for all this x square, x cube, x raised to 4, xy, and x square y. So this is also, remember this normal equations. You have to remember this normal equations. Now example 1. So find a straight line to the following data. Here we have x and y. So this is x1 y1, x2 y2, x3 y3, x4 y4, x5 y5, and x6 y6. So 6 pair we have given of x and y. So now we want to find out a straight line. So y equal to a plus bx. Okay, y equal to a plus bx. So for a straight line, we have a normal equations. This summation y is equal to na plus b summation x. And similar thing here again. Once you remember this first equations, now you have to multiply it. This na it means summation a. Na it means summation a. So if you multiply it with x, what I get summation xy, a into summation x, and b into summation x squared. Okay, so these two normal equations which we use to find out the straight line y equal to a plus bx. Now x and y we have given, so we have to draw a table, and we have to find out this x square and xy as we requiring here summation xy and summation x square. So this is our x, y, and from the x we have find out x square here. 1 square 1, 2 square 4, 3 square 9, 4 square 16, 6 square 36, and 8 square 64. Similar way, x into y. X into y you have to find out. So you get this point. Now sum of all it. So summation x, summation y, summation x square, summation x y. So I get 24, here 24, 130, and 113.2. So we will use put this all point in this equations, and if you put this value in this equations, what I get summation y is equal to 24 and n is equal to 6. So 6a plus 24 into b as summation x equal to 24. Now summation xy, which we have 113.2, is equal to 24a plus 130 into b. So now you have a two linear equations with two variables, and you have to find out a and b. So you can apply the eliminations method. Just eliminate variable a or b. If I want to eliminate a, then what I have to do? I have to multiply it with for these equations, and then I can eliminate a. And after eliminating a, then I get the value of b, and once we get the value of b, you can put this value of b in one of the equations, you get the value of a. So a is equal to here 1.9765 and b is equal to 0.5059. So I hope this is clear for everyone how to find out. So once we get a and b, I get the functions y is equal to this 1.9765 plus 0.5057x. Okay, so if you know the if you remember this normal equations, and just once you remember first one, second one you can easily write this na, which is nothing but summation a. So if you multiply whole equations by x, you get this summation xy, a summation x plus b summation x squared. And one by normal equations we get the idea of what we require. We require summation x squared, we require summation xy, summation x, and summation y. So we require to draw a table and find out this value. Put this value into the normal equation, you get two linear equations in two variable a and b. Now you have to solve these two linear equations, and so a lot of method for this, by eliminations or cross multiplications. Okay, you can find out this eliminations, and a and b, you can find out this a and b. Once you get a and b, this is your straight line equations. Y is equal to 1.9765 plus 0.5059 x. Okay, so now second example, fit the straight line to the following data. Also estimate the value of y at x equal to 2.5. Okay, so once we get this equations y equal to a plus bx, we can find out the value of future value of y, like, or any value. We can predict value of y according to whatever we have x. So here for x equal to 2.5, which we haven't given in data, but we can find out from, once we get the best fit curve, we can find out this y. Okay, so here again the equation of straight line be y equal to a plus bx. Now normal equations, what we get normal equations here, summation y is equal to na plus b summation x, and summation xy is equal to a summation x plus b summation x square. Now we require to draw a table. So I suggest all of you try yourself and find out summation x, summation y, summation x square, and summation xy. In reply in chat box, your answer reply in chat box. Okay, I give you a 2 minute. You can easily do it. So what we get here, summation x, summation x, you easily here 6 and 9 and 10. Okay, summation x is 10. Now summation y, yeah, summation y is equal to 15.9. Summation x square is equal to 30. Now summation xy, summation x into y. What you get here, summation xy. Okay, so summation x, which we get 10, summation y 16.9, not 15.9, 16.9. Okay, let us see. 1, 2.8, 2.8, then 5 and 6.1, 6.1, and 10.6, and 10.6, and so 16.9, which we get 16.9. Summation x square, which I get here 30, and summation xy is 47.1. Once we get this value, you can put this value in equations. Now try yourself and find out a and b. A and b. Okay, try yourself and find out a and b. You have two equations and two unknowns. How you can eliminate a? Just multiply it by 2, equation 3, and subtract from 4. Okay, first get b is equal to 1.33, and a what we get here, a. Once you get b, you can find out a. B is 1.33 is correct, so you get a is equal to 0.73. Just you have to put this value in equation or any of one equation. Okay, you put here some b is equal to 1.33, then multiplied by 10, 13.3, subtract from here and divide by 5, so you get 0.72. Once we get a and b, then we can write the equations y is equal to 0.72 plus 0.33 into x. So this is our fit straight line to the following data. Okay. So now example 3. So this is okay. We require to be find out now. We require to be find out estimate value of y at x equal to 2.5. So once we get this y, now instead of x we have to point 2.5. Okay. Here we have to put 2.5. So we get the value of y. If we put 2.5, y is equal to 4.045. Okay. So at x equal to 2.5, y get 4.045. Now for the data given below, find the law form y equal to a plus b into capital P using least square. Now see here, instead of x, we have given capital P. So in our normal equation, instead of x, we get capital P, and instead of small y, we have given capital Y. So in our normal equation, instead of y, we get capital Y. Okay. Here we want to find out the straight line capital Y is equal to a plus b into capital P. So now our normal equations will be here. Our normal equations, instead of this small y, I get capital Y. So summation capital Y and a plus summation b into summation capital P. And here summation, instead of summation xy, I get summation capital P into capital Y is equal to a into summation capital P plus b into summation capital P square. So in these equations, we have instead of small x capital P and instead of y small y capital Y. So according to that, we get a change in our normal equation. So now what we have to find out? We have to find out summation y, summation p square, summation p into y. Okay. So try yourself first and find out the table. So what you get here? Summation y and summation p. Summation p is equal to, see, this is 140 and 160, so 300, and 180 and 120, 300, and this is 200 and 100, 300. So summation p you get 900. Okay, summation p which you get 900. Now summation y, find out summation y. Now this 0.45 and 0.55, so which I get 1. 0.6 and zero point 0.7, which I get 1.5. So 1 plus 1.5, 2.5. And now we have to find out the sum of these two. 0.5 plus 8.8, so 3.3, 3.3 and 0.85. So 4.15, 4.15. Okay, 3.95. Sorry, summation y is equal to, this is it correct? 1.5. Okay, and this 0.6. Okay, we had forgot this 1 and 1.5, 2.5, 2.5 and 3.1, 3.1 and 3.95. Okay, fine, 3.95. Now summation p square, which I get 1,42,000, and summation py, which I get 621. So put this value in equations. So you get these two equations: 3.956a plus 900b and 621 is equal to 900 plus 1,42,000 So now try yourself and find out A and B. Okay, and reply your answer in chat box. Each one. Awad, Akanksha, Dhoni, Hemangi, Hanvi. Reply your answer in chat box. Kumar Pal. Find out A and B. So what we get here, A and B. Reply your answer in chat box. A and B. Each one have to try this example. Find out A and B. Vaibhav, Urvashi, Shyam, Ruti, Parth, Nancy. What you get here, A and B. Okay, doing. You have just only two linear equations and two variable a and b. So reply your answer in chat box. You have here 6a and here 900a. So multiplied 150 by equation 3. Okay, multiplied 150 to the equation 3 and subtract from equation 4. So you can eliminate a. What you get parts a and b. Reply your answer in chat box. See, this is two linear equations. You can easily solve it. Later on, we have to solve three linear equations for three variable for quadratic equation. Okay, Nancy get a is equal to 0.693. Here a is equal to 0.0476 and b is equal to 0.0041. Okay, so you get these equations. y equal to b is equal to 0041 with 45. Okay, so now example number 4. So just try yourself later on and find out this a and b. Okay, so you get this a and b is 0.0476 and b is equal to 0.0041. These are your equations. Now example number 4, fit a straight line for the following data taking x-axis as a dependent variable. Now see here, x-axis is a dependent variable. It means x is your dependent. So we want to find out the equations x equal to a plus by, x equal to a plus by. So now in normal equations, instead of x we have to write y, and instead of y we have to write x. Okay, so here I get, instead of y, now summation x is equal to na plus b into summation y, and summation yx is equal to a into summation y plus b into summation y square. Okay, as we have here, x is a dependent variable, so our equations is x equal to a plus by. Previously what we have find out, y equal to a plus bx. So now here our straight line equations is x equal to a plus by. So x is dependent on y, so according to we get the change in the normal equations. Now we require to find out summation x, summation y square, and summation y into x. Okay, summation x, summation y square, and summation y x, so which I get 56, 40, 256, and 364. So if we put this value in equations, I get 56 is equal to 8a plus 40b, and 364 is equal to 40a plus 256b. Again, you have to find out a and b. So just multiply equation 3 by 5. 8 5s are 40, and then you can eliminate a. Multiply equation 3 by 5 and subtract from 4. I think you get b is equal to 80, 56. Okay, so multiplied with 5, 280. 84 by 56. B is equal to 84 by 56. It means what? 1.5. Yeah, 1.5. And A is equal to minus 0.5. So now your equations x equal to A is equal to minus 0.5 plus 1.5 y. Okay. So here change is, instead of x you have to write y, and instead of y you have to write x. Now example number 5. Fit a second degree polynomial using least square method to the following data. Now second degree polynomial, it means your parabola y equal to a plus bx plus cx square. a plus bx plus cx square quadratic curve here, and you have three normal equations here. Summation y is equal to na summation b x plus summation cx square, in which you write from this, like, see, this is your y equal to a plus bx plus cx square. Just apply summation on these equations. What I get? Summation y, summation a, it means na, summation b in x, it means b into summation x, and c into summation x square. Once you get this, now multiplied with x, and then apply summation xy, a summation x, b summation x square, c summation x cube, and then multiplied with x square, you get this third equation. So now you require to find out summation x, summation y, x square, x cube, x4, summation xy, and summation x square y. Okay, and n equal to, we have given 5 number of data. Okay, so if we find out this, what I get is summation x is 10, summation y is 12.9, summation x square is 30, x cube is 100, x raised to power 354, xy is equal to 37.1, and x square y is equal to 130.3. So you have to put all this value in this normal equations. Now we get three linear equations in three variable here, a, b, and c, and which you can solve by Gauss eliminations method or Gauss-Jordan method, or by finding inverse of matrix and x equal to a inverse b. So you can apply any of the three method, and you know that how to apply this Gauss eliminations and Gauss-Jordan method. So we are not going to discuss how to find out this. You already know. After applying this method, what you get? A is equal to 0.55, b is equal to minus 1.07, and c is equal to 1.42. Okay, so you have to put this value in quadratic curve. So you get y equal to 0.55 plus minus 1.07x plus 1.42x square. Okay, so instead of now linear equations, you have a quadratic equations, and then you get three linear equations. After finding this value in table, you get three linear equations which you can solve by one of three method: Gauss eliminations, Gauss Jordan, or inverse of a matrix. Okay, and then get ABC. You have to put this value in quadratic equations, so you get the quadratic curve. So now example number 6. Fit a quadratic curve to the following data. So here again, y equal to a plus bx plus cx square, and you have only 4 data. So and normal equations is this: apply the summation on given equations, so you get the first one. Now multiplied with x and apply the second summation in equations, then you get second equations. Again multiplied with x square for this quadratic equations and apply summation, you get this third normal equation. And now find out, try yourself, find out summation x, summation y, summation x square, summation x cube, summation x raised to 4, and reply your answer in chat box. Okay, reply your answer in chat box. Summation x, directly you can see that here 10. 2 plus 3 it means 5, 1 plus 4 it means 5, 5 plus 5 10. And summation y, again this 1.8, 3.2 it means 5, 2.3 and 1.7 it means 4. So you get summation y is equal to 9. So you get here summation x 10, summation y 9, summation x squared 30, summation x cube 100, summation x raised to 4 354, summation xy is equal to 25, and summation x square y is equal to 80.8. So you have to put this value in equation. So we get 9 is equal to 4a plus 10b plus 30c, and 25 is equal to 10a plus 30b plus 100c, and 80.8 is equal to 30a plus 100b plus 354c. So after applying Gauss elimination method, you get a equal to 2, b equal to minus 0.5, and c equal to 0.2. Okay. Now, example. So here you get the, once you find out ABC, you get the y. Example number 7. Fit a parabola using least square method for the following data. Again, you have y equal to a plus bx plus cx square, and your normal equations here, summation y is equal to na plus b into summation x plus c into summation x square. Okay, now you can easily remember these normal equations. If just apply summation on these equations, so you get the first equations multiplied with x and apply the summation, you get the second, multiplied by x square and apply summation, you get the third equation. And you have to find out summation x square, summation y, summation x square, summation x cube, summation x raised to 4, summation xy, and x square y. And if you find out here, then summation x is equal to 15, y is equal to 200, x square 55, x cube 255, 979, 832, 3672. Put this value in equation, you get this three equation. Apply Gauss elimination method and solve it, then you get a equal to 10.4, b equal to minus 11.09, and c equal to 5.71. Okay. Similar manner as we have seen a previous example. So now you know how to find out the quadratic equations by using least square method for a given data. Okay. And here then you get this quadratic curve y equal to 10.4 plus minus 11.09x plus 5.71x square. Now, example number 8. Suppose you have given the curve, parabolic curve like y equal to ax plus bx square. Okay, instead of a plus bx plus cx square, you have given ax plus bx square. So you have only two parameters. So you get only two normal equations here. For this y equal to ax plus bx square. So multiplied with this x, and you get summation xy, a summation x square plus b summation x cube, and multiplied with x square. So and apply summation, then summation x square y, a summation x cube, and b x raised to 4. So here you have to find out a and b only. Okay, and you required in equation is summation x square, summation x cube, summation x raised to 4, summation xy, and summation x square y. So find out the table xy, x square, x cube, x raised to 4, xy, x square y, and put this value in our normal equations. We get this. So previously in quadratic equations we have a plus bx plus cx square. Instead of that, now we have y equal to ax plus bx square. So our normal equations will be summation xy is equal to a summation x square plus b summation x cube, and summation x square y plus a into summation x cube plus b into summation x raised to 4. Then you have to put this value, so you get these two equations. After solving these two equations, you get a and b 2.11 and b is equal to 0.4. Put this value in our parabolic curve, so we get the equation. Okay, so here we stop our presentations, and here we have completed this linear and quadratic equations. Okay, so remaining logarithm curve, which we will discuss in next session. So here we are ending our session, and we are